Calculus, find area between curves. This problem we're going to be working, this one I'm showing right here, comes from a recent homework assignment. And it will be for these three problems. We're going to take, it says area of region between two curves. Homework for each problem, sketch the region bounded by the graphs of the functions and find the region of the area. And so we're going to zero in on this problem, number 2. And so let's go take a look at it. We've got two equations in terms of y. So here they are. We have two curves, and we can see that we have two quadratic equations. So we know that our area bounded is going to look something like this. We're going to have a downward opening parabola and an upward opening parabola. And so we're going to find the limits of integration and take this area here and find this area by subtracting and so forth. So first of all, let's find the limits of integration by setting these two equations equal to each other. So to do that, I'm going to say x squared minus 4x plus 2 is equal to negative x squared plus 2x plus 3. And we're going to solve this equation by setting one side of the equation equal to 0. And for this, I'm going to add on the right side x squared, subtract 2 squared, and subtract 3. And that's going to make our right side equal to 0. And doing the same thing on the left side, we're going to add x squared. We're going to subtract 2 squared. And we are going to subtract 3. Now I notice right off the bat that I made a mistake on this. And it's supposed to be plus 3. Okay, that's plus 3. There we go. So now we go ahead and we have 0 on the right side, cancel out. So we have 2x squared minus 6x, and 3 minus 3 equals 0. So solving by factoring, we have 2x as our common factor in these two terms. So we have times 20x minus 3 equals 0. So therefore we know that we have x equals 0 and x equals 3 as our limits of integration. And so what that tells us is that our little sketch up here is not perfectly accurate on the coordinate plane, but if we move it over here, I'm going to move it over like this. Is that going to work out right? Yeah, if we can move it like this, we're going to be able to just draw in a 0 here and a 3 to just conceptually accurately figure the area. Now in reality, we're going to have a intersection is going to occur at our y-intercept of 3 up here. So we'll look exactly like this, but for our conceptual purposes, this is good. So let's go ahead. When we find the area between two curves, our area is going to be the integral from a to b of a function f of x minus g of x, our lower function, dx. And in this instance, our upper function here is going to be this negative curve. So f of x is going to be equal to negative x squared plus 2x plus 3. And our lower function g of x is going to be x squared minus 4x plus 3. Okay, so let's let's work this out now. I have area is equal to, and we found that our limits of integration are from 0 to 3. That's going to be our equivalent for a and b. A equals 0, b equals 3. And we're going to have f of x minus g of x. Well, f of x, our upper function, must be negative x squared plus 2x plus 3. And we're going to subtract out g of x, which is x squared minus 4x plus 3. And that's going to be dx. And just simplifying, I'm just going to go down here. A equals from 0 to 3. We're going to have negative x squared minus x squared. So that's going to be negative 2x squared. And then we're going to have 2x minus negative 4x, which is going to be plus 6x. And dx. And working to the right, integrating, we're going to have negative 2 x to cube over 3 plus 6x squared over 2, and we're integrating between our limits of 0 to 3. And continuing to work to the right, we're going to have negative 2, we're going to have 3 cubed over 3 plus 6, 3 squared over 2. That's going to simplify to 3. And just working below, and plus we're going to subtract out our 0. So we're going to subtract out this thing right here, negative 2 times 0 cubed over 3 plus, that 6 over 2 is 3. We'll have 3, 0 squared over 2. Okay, and this is going to end up being 0. So we're left with negative 2, and 3 cubed is 27 over 3 plus 6 times 3 squared. Well, that's going to be, we'll just make this 3 here, right? So 3 times 3 squared is going to be 3 times 9. And that's going to be equal to negative 2 times 27 divided by 3. Negative 2 times 9 plus 3 times 9 is 27. And that's going to be negative 18 plus 27 is equal to 9. So 9 is our answer. Our area equals 9 units. So I hope this has been helpful. Take a look at these other problems, these numbers 1 and 3, see if you can get those right. I hope that this video lesson has been helpful to you. Good luck. Thanks for viewing.